Greater efficiency in the national airspace system begins and ends on the airport surface. Moving traffic more effectively between ramp areas, taxiways, and runways means fewer delays, less fuel burn, and reduced carbon emissions. Key to that efficiency is the sharing of flight status data. Tools and infrastructure being deployed today are laying the groundwork for the collaborative environment that will ultimately enable controllers, pilots, and airline operation centers to work together to ensure the most efficient surface traffic management. One of the most promising tools now in development is the Flight Data Object, a constant, dynamic stream of comprehensive flight status data designed to automatically update the systems the FAA and the airlines use to track aircraft and make collaborative traffic management decisions. Surface flight data objects are assigned when the airline files flight plans. Optimal pushback times, runway assignments, and taxi routes are calculated, and controllers sign off on the recommendations. The information goes into the Surface Flight Data Object, which connects to FAA and airline systems. Pilots get the information through a data communications uplink.
That today all has to be done via voice, and that's voice and calls are a not very convenient, not very efficient method.
To check the Flight Data Object's potential to improve surface efficiency, a team of FAA researchers and industry representatives gathered for a Surface Flight Data Object demonstration at the FAA's Daytona Beach, Florida NextGen testbed. They followed the Surface Flight Data Object, or SFDO, through both arrival and departure scenarios. For this test, NextGen Flight 1 is out of Daytona Beach, bound for Charlotte. NextGen Flight 2 starts out in Orlando, also bound for Charlotte. The airline files flight plans for both aircraft, creating an SFDO for each flight. This feeds into tools that calculate optimal pushback times, runway assignments, and taxi routes. The Orlando flight was scheduled to depart first, but a storm moves in, delaying the flight and possibly delaying flights at other airports. The Orlando controller orders a hold and modifies the Surface Flight Data Object, which automatically updates the airline, giving them the information they need to consider their options. The airline asks if its Daytona Beach flight can be released and put into the flow earlier to take advantage of the new opening in Charlotte. The Daytona Beach controller agrees and accepts a new departure time calculated by the Surface Decision tool. Once again, the Surface Flight Data Object updates FAA and airline systems, and the new clearance is linked to the cockpit. As Flight 1 taxis, it is automatically monitored to make sure it is on the right route to the correct runway. After the Daytona Beach flight departs, the weather in Orlando clears and Flight 2 takes off. As the flights converge on Charlotte, Flight Data Object provides FAA and airline systems with predicted arrival times. With this data, optimal runway assignments, taxi routes, and gate availability are calculated and planned. Conformance monitoring signals pilots along the proper trajectory to the correct runway and taxi route. As the aircraft arrive at the proper gates, the Surface Flight Data Object updates FAA and airline systems to indicate the flights are complete. An international component of the demonstration highlighted how the SFDO could interact with overseas systems, relaying information regarding a ground delay at London's Heathrow Airport to the destination airport in the United States. U.S. controllers were able to use that information to adjust arrival slots, maximizing airport capacity.
And actually, I think what we've proved is that we can today link systems together in real time, show genuine operational benefits.
The development of the Flight Data Object is an ongoing process. The Surface demo built upon an earlier international Flight Data Object demonstration, and future demonstrations are expected to further refine the concept in fiscal years 2011 and 2012.
For more information about the NextGen transformation, visit the NextGen website at www.faa.gov/nextgen. From the Daytona Beach, Florida NextGen testbed, I'm Bill Gordon.